Okay, so now let's start for the geometrical and optical isomerism shown by the complex octahedral complex of the type MAA A2B2. Here A is a identity ligand, as we already know. So these are the possible pairs in this. A is trans to B, A is trans to A is trans to small b. So in this case AB, AA, AB, so none of the trans pairs are getting repeated and the same ligand is not trans to each other, so this is optically active. The next possible pair for this is A is trans to small a, capital A is trans to again small a, and B is trans to B. So this we can see is a optically inactive pair because B is trans to B and the trans pair is getting repeated. So this is optically inactive. In the next possible pair, we have A trans to B, A trans to B, and A trans to A. Again we can see that the trans pair is getting repeated and A is trans to A. So this is also optically inactive. So till now we got 3 possible pairs, and out of these 3 possible pairs 2 were optically inactive whereas 1 was optically active. So now let's go on to the calculations and see what will be the number of geometrical isomers, stereoisomers, optical isomers, and enantiomeric pairs. Number of geometrical isomers is equal to the number of possible pairs, so that will be equal to 3. The number of optical isomers is equal to the number, it depends upon the number of the optically active pairs, and the optically active pair was 1, so the number of optical isomers is going to be 2. Again this is 3, this is 2. Number of enantiomeric pairs is the number of optical isomers divided by 2. So that's 2 divided by 2, which is equal to 1. Again 3, we have 2 and 1. Now total number of stereoisomers is equal to the number of optical isomers plus the number of optically inactive possible pairs. Optical isomers are 2 and optically inactive isomer pair were also 2. So that's 2 plus 2, 2 plus 2 is 4. So these were the total possible isomerism in the complex of the type MAA A2B2, in which AA is a didentate ligand in which both the donor atoms are the same. So next we come to the octahedral complexes of the type MAA to A2. So in this the didentate ligand is also present twice and the unidentate ligand is also present twice. So we look on to the possible pair. So this is the first possible pair. Okay, so in this you can see that A is trans to A. But I had told you that when there is a didentate ligand, you cannot possibly keep the same ligand in the trans pair. But there is a catch to this rule also. If the number of the didentate ligands is greater than 1, then you can keep the donor atoms or the didentate ligands in the same trans pair. That is why A is trans to A in this case. So A is trans to A. Okay, you will see how it will work out. Then A is trans to small a, then A is trans to small a. See, angles are still maintained. So again here AA, it's a trans pair is getting repeated, so we have optically inactive pair. Then we have the next possible pair. In the next possible pair, A is trans to A. Again capital A is trans to capital A and small a is trans to small a. So small a is trans to small a as well as the trans pairs are getting repeated. So this is also optically inactive. Okay, so now these are also known as a different type of isomerism. In this you can see that both of the didentate ligands are trans to each other. So this is known as a trans isomer, whereas the previous one is a cis isomer. Okay, so the didentate ligands are present at an angle of 90 degree to each other, whereas in the next case the didentate ligands are present at an angle of 180 degree to each other. So now let's calculate the total number of geometrical isomers. You know the total number of geometrical isomers is equal to the number of possible pairs. So that's 2. Then we have the number of optical isomers. So there were no optically active isomers, so that's going to be 0. Then we have the number of enantiomeric pairs, which is again going to be 0 because optical isomers is 0. Then we have the number of stereoisomers. So stereoisomers is going to be number of optical isomers, that is 0 plus inactive pairs. So that's 2. So total is 2. So this were all types of isomerism which is possible in the complexes of the type MAA to A2, in which the didentate ligand was also present twice as well as the unidentate ligand.